Hi, rabbits. Research Turtle here. We stand at a profound turning point in the second half of 2026. Tesla has successfully evolved from spatial vehicle optimization to true temporal and physical AI. However, this breathtaking visionary trajectory has collided with a hard reality, as it is now fundamentally constrained by the laws of physics. Overcoming these physical limitations demands a perfectly vertically integrated hardware stack, encompassing foundry, memory, vision, and power. Right now, this turnkey architectural capability is possessed solely by the Samsung Alliance. To understand why this hardware is absolutely necessary, we must first look at the recent software leap. Tesla has moved entirely away from the snapshot AI of FSD version 12. With versions 13 and 14, they have transitioned to temporal transformers, granting the system up to 15 seconds of physical state prediction. This unlocks true object permanence. No longer will the system suffer from micro-hesitations if a pedestrian steps behind a parked truck. Combined with Occupancy Network 3.0, which increases front camera 3D voxel resolution by an astonishing 800% to a 1 cubic decimeter density, the result is human-like, jerk-limited path planning capable of navigating complex, unmapped environments. But this software brilliance has exposed a brutal hardware wall. When we compare the legacy Hardware 3 against the modern Hardware 4, the performance ceiling is glaring. Hardware 4 natively runs the original world model in FP16 precision using 5.44 megapixel cameras. Its miles between interventions are scaling beautifully at roughly 450 miles. Hardware 3, however, is bottlenecked at 1.2 megapixels, forcing a reliance on a distilled V14 Lite model using INT8 quantization. The network pruning required for this causes inevitable data loss, leaving its safety metrics stagnated at roughly 120 miles between interventions. The strategic conclusion is inescapable. The 4 million vehicle Hardware 3 fleet lacks the memory bandwidth for unsupervised FSD, posing a massive legacy upgrade dilemma. How does Tesla break through this memory bottleneck? The immediate bridge is the AI 4.1 board, arriving in mid-2027, which doubles system-on-chip memory from 16 gigabytes to 32 gigabytes to alleviate immediate neural network congestion. But the true revolution is the AI 5 compute engine. This 2-nanometer crucible packs 3,000 to 4,000 TOPS, demanding up to 800 watts of power. Dual chips rival NVIDIA's Blackwell architecture. Crucially, it integrates a staggering 192 gigabytes of RAM directly on package via 12 memory modules. To mitigate geopolitical risk, tape-out is confirmed at both Samsung's Taylor Fab in Texas and TSMC. This extreme memory integration highlights a calculated dual strategy between the edge and the cloud. At the edge, for robots and cars, Tesla is utilizing 12-nanometer class LPDDR6 integrated onto AI5. It delivers a 10.7 gigabits per second data transfer rate with a dual sub-channel architecture. Most importantly, its dynamic power management yields a 21% increase in power efficiency, an absolute requirement for battery-constrained robotaxis and humanoids. Meanwhile, in the cloud, Samsung's 6th-generation HBM4 memory, built on a 4-nanometer logic base die, eliminates the training choke point for Tesla's Dojo 3 infrastructure and multi-exabyte video processing clusters. It boasts a blistering 3.3 terabytes per second bandwidth, peaking at 13 gigabits per second. For all this compute to matter, the physical AI must see the world flawlessly. Samsung Electromechanics has secured 80% of Tesla's camera supply, replacing legacy vendors with highly durable glass and plastic hybrid lenses for radarless vision. At the core is the ISOCELL corner pixel solution. By combining a 1.0 micrometer photodiode to capture highlights and a 3.0 micrometer photodiode for shadows, it captures 120 decibels of extreme dynamic range simultaneously. This completely prevents the dangerous whiteout effect when exiting tunnels. Furthermore, its LED flicker mitigation extends exposure on the smaller photodiode to entirely absorb LED pulses, preventing traffic lights and digital signs from appearing blank to the AI. This mastery of vision and compute culminates beautifully in the Gen 3 Optimus humanoid. Physical AI is now manifested with 22 degrees of freedom in the hands, doubled from Gen 2, enabling fully human-like discrete tasks, such as handling eggs or threading needles. Through a brilliant tendon pole architecture, heavy motors were relocated from the hand to the forearm, drastically reducing center of gravity inertia. The forearm itself now packs 25 micro-actuators directly into its density. For heavy lifting, planetary roller screws achieve 3-micron precision across 300mm strokes. Driving the unit cost of these components from $2,700 down below $1,000 is the final barrier to achieving a retail goal of under $20,000. Scaling this robot, however, introduces a massive vulnerability known as the O-chain dilemma. Tesla's goal of scaling to 1 million units per year relies on a Tier 1 Chinese ecosystem that is highly vulnerable to shifting export controls and trade friction. Sanwa Intelligent Controls captures roughly 19% of the bill of materials, dominating the supply of linear and rotary actuators. Green Harmonic supplies over 60% of joint reducers, undercutting legacy Japanese monopolies by 40%. Coupled with an absolute reliance on Chinese neodymium permanent magnets, this ecosystem represents a severe strategic risk. Even if supply chains hold, humanoids face a critical form factor crisis. Traditional electric vehicle batteries simply fail humanoids. EVs require slow, continuous discharge with distributed weight across a large floor pan. Humanoid jumping, lifting, and balancing demand explosive high-current bursts. Current NCM batteries yield only a 2-hour active runtime, ruining workforce continuity, and operating them in close proximity to human workers makes the liquid electrolyte volatility an unacceptable thermal runaway hazard. LFP batteries are simply too heavy for bipedal dynamics. The ultimate enabler for the 8-hour shift is Samsung SDI's solid-state battery. By achieving 1,000 watt-hours per liter, this leap in energy density allows a full 5 to 8-hour shift capability. Crucially, the solid electrolyte drops the thermal runaway risk to absolute zero. A pilot line is currently running, with massive commercial scaling targeted for late 2027. Looking at the broader macroeconomic landscape, we are witnessing a permanent hardware decoupling. The era of software-defined vehicles has collided with physical silicon limits. Because AI architecture evolves vastly faster than automotive sheet metal, automakers will be forced into smartphone-style modular hardware upgrade cycles. Failing to adopt this modularity risks massive consumer backlash and hard L4 capability ceilings. To navigate this obsolescence gap, Tesla is driving the terraferrabrelement. Tesla aims for a 9-month AI chip design cycle, which fundamentally clashes with the multi-year stabilization physics of 2-nanometer foundry nodes, which are currently hovering at 50 to 60% yield. To break the TSMC and Samsung duopoly and secure sovereignty over its AI 6 and Dojo 3 production, Tesla has partnered with Intel's 14A process to create a centralized megafacility. Simultaneously, Tesla's compute footprint is expanding beyond traditional data centers towards space-based compute, integrating with SpaceX and xAI for limitless solar power. Ultimately, this all synthesizes around the integrated turnkey architect. Samsung is the world's only integrated device manufacturer capable of cross-optimizing logic, memory, vision, and power at scale. This alliance elevates them from memory cycle dependency into the preeminent AI turnkey platform. 2026 is the commercial tipping point. Tesla's unprecedented software imagination has finally arrived on the commercial ledger. Unsupervised autonomy and general-purpose robotics are no longer algorithmic challenges. Ultimate victory is now entirely subjugated to the physical execution, yield rates, and thermodynamic breakthroughs of its hardware alliance. That's it for today. Turtle out.